Today is a good day. Why? Because I'm going to get you thinking about chocolate today. And I know you like chocolate, right? A lot of people like chocolate. And there's a lot of reasons why not to like chocolate, right? It's very interesting. Why? Because chocolate is a magical thing. Chocolate can make you have a stomachache. It can make you fall in love. It can make you do things that you didn't want to do before. Oh yes. But why is that important? Well, I want to get you thinking about the way chocolate's made. Yeah? How is chocolate made? Well, you temper it, you can caramelize it, you do different things, right? Now here's the fun bit. How does that work with software? Right? If we were to put that against software, what do we get? Well, you can do different things, right? If the temperature is too high, you can burn the chocolate. Perfectly reasonable. You can come out with different tempers. So for example, rather than having bubbles, you end up with a smooth layer of chocolate. Can happen. You can end up with a hard chocolate, a soft chocolate, all these different kind of things for chocolate. So, how does that fit into something like containers? Well, where do you put chocolate? In a container, right? You're going to put it inside of a wrapper. And that's the thing, right? If chocolate was left outside, it would melt, right? It would just melt. It would just be like, hello, yes, now I will melt in your hands. I don't mind if I'm on ice cream or whatever. It will just melt. Yes? Not exactly what we want. And that's kind of what's happening in software at the moment. You know, we build all these great apps, but they only work on individual machines, which is not great. So this is why Docker was created, as a means to wrap things so that way it works across different systems. So think of it like a magical gift box for your software. Not my words, ChatGPT, right? It says a magical gift box for your software. And it was talking about a toy box. I didn't even go into the toy box. Yeah? But you can think about it as a toy box, you know, where you put things inside of the toys inside of the toy box. That's one way to think about it. I didn't go down that route because I think chocolate's nicer. Let's leave out chocolate. But anyway, so mutable. What we're going to be discussing now is things around mutable versus immutability, and containers versus VMs, and the best practice. Okay, so let's go into mutable versus immutable. So let's say you got some Lego bricks, right? And let's say it's like Tetris. You're playing Tetris, but it's Lego bricks. You know when you play Tetris, you know when you put all the bricks in, yeah? It goes do 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 do. I am putting things right in here, yeah, and then it goes like that, right? It all goes away. That's mutable software. Why? Because it forever changes. What's immutable software? Well, immutable software is like your brick wall, right? It doesn't go anywhere unless you hit it with a sledgehammer or drive a truck into it. There you go. Immutable versus immutable in about, I don't know, 30 seconds. All right? So why is that important in software? Because when we create Docker containers, we don't want the Docker container itself to be mutable. We don't want it to change. Unless we've got things like a software update, then it makes sense, right? So yeah, that's mutable versus immutable. Right, what's a container versus VM? And why is that important? Well, think about it this way. I have my cookie. This is a really nice cookie. And I mean, this is nice, right? Gorgeous little cookie. Now, with a container, this is what I'm doing. Yeah? It's just in a cup. I have my cookie. I eat it. Job done. Nothing more, nothing less. Because all I'm interested in is the cookie itself and the minimal thing that I can put it in, which is, in this case, the cup. In a lot of cases, if you're a bakery, it'll be the wrapper. Yeah? It's the minimal thing. A virtual machine is like saying, I want to have the whole bakery to make this cookie. You can do it that way, because you now have everything that you need. But that's a bit like a VM. I've got extra overhead in order to run my application, which is just not needed. All I need is just to run the application as is by itself, with the minimum amount of information that is needed in order for the application to run. Yeah, that is a container. Anything more than that, and we're talking about a VM. And that goes into the next point about slim images. Right? So how do I describe that? Well, think about it this way. You have just ingested 20,000 calories. Congratulations. Right? Now, if you go on a treadmill with 20,000 calories, you're not going to lose it overnight. Right? It's going to take a long time to lose that calorie. Yeah? But what can you do to speed up the process? Well, you could starve, because now you have no ingestion, and that's possible. I wouldn't recommend it, but you could. And then the next part is that you can actually reduce the amount of calories. Why? Because you don't want to starve. You can reduce the amount of calories, and that way, by doing so, right, energy out, because now you're going walking, you're going running, you're doing more things, is increased over energy in, which is the amount of calories. Yeah? Therefore, you end up losing the weight. Yeah? So you end up in that kind of situation, which is really, really good. It's positive. So that's the idea of using slim images. Why? Because by doing so, right, you end up with that very, very nice figure. Yeah? Hey, I'm just saying, I'm trying to make it fun, right? You know, people go to the gym for figures, right? That's generally what you go in for. So you can have a really, really nice figure, or, you know, you don't. It's kind of like that, right? I mean, apples and oranges. It's, you know, it's up to you what you're going to the gym for. I'm not judging, but you get the idea that I'm trying to portray, which is like, okay, you should be using slim images because you want to keep it small, so that way it doesn't take long to build. Okay, there you go. Don't judge. I'm just putting information out there. Okay, cool. Next part is a multi-stage build. Right. Okay, multi-stage build. Right. You're gonna like this one. This one you're gonna love this. Okay. Cool. I'm gonna make it in such a way that you'll never forget what a multi-stage build is ever again. Okay. There is water. Okay. Now this water has, this jar has some water in it, right? So now this jar is what I like to call container 0. Which means that from this jar, I want to put that into this jar, which could be a scratch container. This is a scratch container right now because there's nothing in it. So now what I could say is that from the jar with water, which is 0, index of 0, I want to put it into my scratch container of index 1. So what does that mean? I take the water. I take my container. And this is what happens inside of the build context. I take said water. I put it into the jar. I now toss jar over there. Jar goes bye-bye. This jar, ta-da, has the water in it. Multi-stage build. Now tell me that wasn't a good explanation. Tell me. Right? That was awesome, right? Explains everything. And this is exactly how I learned multi-stage build myself. I found it quite a difficult thing to get my head around initially. But then when I just thought about this, I was like, this is really cool because this explains exactly what's going on down in the build Docker context. Right? Is that container becomes ephemeral. In other words, it's not going to be there all the time. Sorry, immutable. I'm getting my words mixed up. What I'm talking about is that this container goes away after a certain time. Right? Once it's done, we don't care about it anymore. It's still within our recipe, but we don't care about it. It's just there. This is the one that we care about, right? Because the scratch container now has the binary that we need, which means it's now slim, viable, and we can just ship it. Next part. We want to talk about env variables. M variables. Nice. Okay. Now, we're talking about chocolate, right? This little thing here. This cookie. So, if I wanted to keep this recipe for this cookie secret, but still be able to make the cookie, how do we do it? Well, we could pass the secret as an env, instead of hard coding it, because it makes it more safer. And that would be a good use case for an env file. We could say, okay, well, I just want to make, I want to change certain things about the recipe about my cookie. So if I want to change certain things about the recipe of my cookie, what I can say is, well, okay, maybe I want to change the amount of nuts that I put in. Instead of putting like 500 grams in for this particular batch, I'll put 300 grams in. That's called a variable. And that's what we use env files for. Therefore, making adjustments when we need them, which are unknown. So rather than saying, right, okay, my recipe is not going to change, it might do, but the product which I'm creating, the actual cookie itself, is not going to change because it's always going to be a cookie. It's not going to be a chocolate bar. It's not going to be a sweet. It's always going to be a cookie or a chocolate, right? We're going to call this a chocolate. But I might just change an amount that I put into this chocolate. And that would be a good use case for an env file. Ever get that in an interview? There you go. Run as nonroot user. So, run as nonroot user. How would we go about this? Say, for example, you're a head chef. Head chef comes in. He says, yo, man, like, the thing that you're making? Absolutely brilliant. Now, I'm going to take it from here. I'm going to make the things that I need to do. Cool. So, chef goes in, creates the chocolate. Now, let's say, the accountant comes in, and now he starts making chocolate. Why is an accountant making chocolate? Shouldn't he be doing stuff in numbers? Right? And that's what we're talking about. You see the security risk there? Now I've got somebody who doesn't know how to make chocolate making chocolate. Is he trained to make chocolate? Probably not, right? So if that's the case, then we're saying, right, that person is running as a non-root user. Sorry, he's running as a root user and he shouldn't be, right? So what do? So we say, okay, well, we can put like a key on a door and say only the head chef can use the key for the door to get in there. Yeah? And that's essentially what we're doing. Which is pretty cool. Yeah, which is pretty cool. But the thing that I'm trying to say here is that, well, as a non-root user, what we're saying is, right, okay, we just want the application to run as a non-root user. We don't want him to install anything else inside of the Docker container. Yeah? We just want to make sure that only the root user can install things. Non-root user only needs to execute the package. We don't need the root user after all the installation of the packages to make our container run. And that's basically what we're saying. Okay, so now the next part that we want to make sure is that we want to keep the host up to date. So what we want to make sure is that our recipe is still good. Yeah, our recipe is still good and that we have everything that we need to eat the chocolate so it tastes nice. Yeah. If we didn't make the chocolate taste nice, there would be no point, right? You wouldn't go out and buy it from the store. So if that's the case, that's basically what we want to do. Yeah? So in other words, in terms of software, very, very easy. Think of it like ensuring that the recipe is still fine, like the milk that goes into the chocolate is still good. The sugar that goes into the chocolate is still good. The nuts that we're using are still in the expiration date. Because if they aren't, then, we can create a health hazard. Our customers won't be very happy. And then on top of that, somebody might end up dead, right? Like Gordon Ramsay says, you might kill someone, right? So we want to make sure that, our chocolate is still good. We're serving customers, making them happy, and we're doing it inside of a timely manner. Yeah? And that's basically all DevOps is. I would just explain DevOps in about 15 minutes. So I hope that you've enjoyed this video. And in the next one, we'll go into a bit more detail about the code. If you've liked this video, please like it. If you didn't, I'm sorry. I'm sure there's some more stuff that can be done to improve the level of interaction. And yeah, I'm available for hire. So if anybody's hiring, let me know. And on top of that, if you want some consultancy on your particular projects, let me know as well. Always open. Appreciate it. Thank you for watching, and goodbye.